SwayamPrabha. Digital India. Educated India.
Hello friends, now we will discuss on the second part of the module, gasification. In the first part of this module, we have discussed on the fundamentals of gasification processes, the process flow sheets, advantages, etc., and we have also made some introductory discussion on different types of gasifiers for coal gasification. In this module, we will discuss on the gasifiers for biomass and wastes, advanced gasification process, plasma gasification, and the comparison between incineration and gasification. Now, we will make some more discussion and comparison among three conventional gasifiers which are used for coal gasification, basically fixed bed, fluidized bed and entrained bed gasifiers, because the same concept will be applicable for the development of the gasifiers for biomass and wastes. In the previous part, we have seen that for fixed bed gasifier, the temperature is maximum at the combustion zone for coal gasification, and then it decreases. This is along height and this is temperature. And for fluidized bed, we had seen that the temperature is almost constant and very high up to certain height of the gasifier, but above that the gasifier, the temperature is small, less. And for entrained bed, we had seen that along the height the temperature is very high. Now, we will be considering some more parameters for comparison. The number one, say gasifier temperature. So, for fixed bed, this temperature is very high, so around say 1500 to 1800 degree centigrade. For fluidized bed, this is let's say 900 or say 1100 degree centigrade, and entrained bed, this is say 14 to 1500 degree centigrade. If we think about the size, particle size, then particle size for fixed bed is bigger, say 2 to 50 millimeter. Here the fluidized bed 0.5 to 5 millimeter, and for entrained bed this is less than 200 mesh, that is around 70 micrometer. If we think about the oxygen requirement, then that is oxygen by feed ratio. In this case, this is around 0.64 normal meter cube per kg, and for this is 0.37 normal meter cube per kg, whereas for entrained bed this is higher, 1.17 normal meter cube per kg. Then gas outlet temperature, if we think gas outlet temperature for fixed bed, this is lesser, say 5 or 600 degree like this. So, 400 to 500 degree centigrade, but here we will get around say 800 to 900 degree centigrade, and here we will get more, say 1200 to 1300 degree centigrade. So, these are the basic parameters which we can compare, and we also compare the quality of the syngas. So, quality of the syngas for fixed bed, syngas quality, it will be containing good amount of tar. So, tar and phenolics. here fluidized bed also will be having tar and char. Char particles will also be carried away through the off gas and will be available in the into this syngas. But for entrained bed we will not get no tar and CH4 is also less. So, quality wise this entrained bed is the superior one. If we replace coal by biomass and waste in these conventional gasifier systems, we will also seeing the similar trend, but there will be some difference as the coal is very less reactive with comparison to biomass and waste. So, the temperature requirement for biomass and waste gasifier will be lower than these values will be lower. So, the gas outlet temperature will also be lower, and as the biomass and waste are lighter than coal, so the particle size can be handled for biomass and waste gasification will also be more than this size. Oxygen requirement will also be different because in biomass and waste more amount of oxygen is available with comparison to coal. But the similar phenomena, similar trend we will see. Now, we will discuss on different types of gasifiers for biomass and waste. The first gasifier for biomass and waste gasification is of fixed bed type, and fixed bed gasifier is divided into two types, that is updraft and downdraft. In updraft gasifier was developed in 1976 by Georgia Institute of Technology, and in this gasifier, just like fixed bed gasifier for coal, the material or waste or biomass is put from the top and from the bottom gasifying agent. This can be oxygen, steam. So, the biomass and waste and the gasifying agent is getting less time for contact because there is some counter current flow, and when the material is coming down, bigger size particles and the gasifying agent is going up. So, there is a good chance of the blocking of this and channeling. So, there will be chance of channeling and bridging. So, these are the disadvantage of this process, and another most important disadvantage of this process is that the outlet temperature is 250 degree centigrade, whereas the inlet temperature inside the combustion zone temperature is around 1000 degree centigrade. This is for updraft fixed bed gasifier for biomass and waste. So, due to this low temperature and less contact time, the syngas will be containing high amount of tar, around 25% tar is present in case of updraft biomass gasifiers. And to remove this disadvantage of this updraft gasifier, as shown here, the new development of this gasifier was downdraft gasifier. In downdraft gasifier, the waste is put from the side and gasifying agent is also put from the middle part. So, here we are giving gasifying agent and we are giving here the waste or biomass, and we are collecting syngas here, So, the material and gasifying agent is flowing parallelly inside the gasifier and getting more chance for contact and reactions. That is why the syngas is getting more better quality than that of the updraft gasifier, and as the temperature is also higher than 250 degree centigrade. So, tar content is less here, but the disadvantage of this gasifier type is that the scale up problem. This gasifier has some scale up problem. The temperature inside this is around say 1000 degree centigrade. again it is 1000 degree centigrade. Now we will see for fixed bed gasifier fluidized bed gasifier. So, fluidized bed gasifier, the temperature is lesser than the fixed bed. So, it is within 500 to 900 degree centigrade, and the particles are also smaller than this fixed bed or almost similar to fixed bed. Depending upon the velocity of the gasifying agent, we can get basically two types of fluidized bed gasifier. One is your bubbling fluidized bed and another is your circulating fluidized bed. So, this bubbling fluidized bed and circulatory fluidized bed, the main difference is that the gasifying agent's velocity is higher in case of circulating fluidized bed, and the unconverted materials are recycled to the gasifier. So, here some heating media is required, sand media is used for the transfer of heat. This system has some advantage that it can produce larger amount of syngas and handle larger volume of the gasification media, and it has some disadvantage that the quality of syngas is not that good. It is having some more amount of CH4 or methane and some tar also, and also it has high carbon or char particles in the syngas. The new development for the biomass and waste gasifications through fluidization is that dual fluidized bed gasifier. In dual fluidized bed gasifier, two chambers are used. The first is combustor and the second is gasifier. So, in the combustor we send controlled amount of oxygen, and in the gasifier we send steam. So, the gasification reactions going on. Now, we will go to discuss on the entrained bed gasifier. So, entrained bed gasifier, in this case biomass or waste and gasifying agent oxygen or steam, all are put inside the gasifier from the top, and the solids and the gasifying agents flow parallelly, gets more time for contact, and temperature inside is also very high. So, this is around say 1200 to 1400 degree centigrade. So, that high temperature, high contact time, and particle size is also less. So, all these factors helps to get more conversion and to produce good quality syngas. This syngas contains less CH4, no carbon, no char, and no tar. This is a superior quality of syngas, and this syngas is mostly suitable for chemical production, and this is also suitable for very large scale production. These are three conventional gasifiers which are developed on the concept of coal gasification. Later on, a new type of gasifiers has been developed for the gasification of biomass and waste, particularly those portions of the solid waste those are hazardous in nature. So, this new type of gasifiers which is developed, that is called as plasma gasifier. So, in case of plasma gasifier, unlike other conventional gasifiers, we do not need to send gasifying agents like oxygen or steam. In spite of that, we need to give some high voltage across two electrode. So, high voltage given across these two electrode produces plasma torch, and that creates very high temperature here, that is say 4000 degree centigrade to 7000 degree centigrade. So, this high temperature generated here helps the conversions of the solid waste present in it and biomass present in it to gaseous products, and when carbonaceous feedstocks comes inside this, so CO and H2 rich gas is obtained under certain condition. The advantage of this gasification system is that no oxygen stream is required, any type of solid waste can be used here, no pretreatment is required, and the quality of the syngas, is very high quality syngas. Why high quality? The high temperature that helps to neutralize the acid gases. This high temperature helps to convert all the metals in ash to its metallic form. So, the slag which is formed here that is in pure metal form, or this material is having very less leaching property. So, nothing is leachable here. So, the management of this is easy and that can be directly used also. So, that is the advantage of this system, but this is not so well matured or extensive research is going on for the commercializations of this plant or this reactor. Now, we will see the mechanism of the plasma gasification, how the mechanism differs from that of conventional gasifiers. In conventional gasifiers, we have seen that for the gasification some other fuels is burnt at the initial stage, then the biomass or waste or any carbonaceous material is partially combusted to produce heat. In this case, that initial firing is different. We need to provide high temperature by the application of high voltage across two electrode, and these two electrode when it is under high voltage will accelerate the velocity of electron generated here. So, free electrons velocity will be accelerated. So, this free electron will then try to collide with nearby molecules, disintegrate it and to generate further electrons. So, when it is colliding other molecules, so it will help to create further electron. When these will collide other molecules, again these will give further electron. So, number of electrons will gradually increase. So, number of electrons will gradually increase and that will proceed, and that will create one avalanche or streamer of this electron, and then this streamer, when the more voltage will be applied, will generate high temperature as well as it will produce different radicals from these materials. From these materials they will produce different radicals like say OH, O, H2O2, O3 is also, O3 can also be produced depending upon the severity of the conditions. And under certain conditions, if carbonaceous material is put here in plasma gasifiers, then the predominating product in gaseous phase is CO and H2. So, this is the fundamental mechanism for the production of syngas in plasma gasifier. Now, we will see how can we select a suitable gasifier type for a particular biomass and waste feedstock. On the basis of these discussions, it is very clear to that the different conventional gasifiers can handle different particle size of the biomass and waste. So, in this case fixed weight, the typical particle size is 50 to 150 millimeter. So, this is bigger than the corresponding value for coal gasifications in fixed weight. For fluidized weight, again it is 50 to 150 millimeter, but in case of entrained weight we are getting less than 1 millimeter, and for circulatory fluidized weight this is less than 20 millimeter. So, the particle size here is relatively bigger than that of the coal gasification gasifiers, but for plasma gasifiers there is no limitation, any particle size can be used. And here is one important thing, that moisture content the moisture content in biomass is very high with respect to coal, but these fixed weight, fluidized weight and these reactors or gasifiers can handle biomass with high amount of moisture, but for entrained weight the moisture content is less. But plasma gasifier, any moisture can be used. Now we will see some technology licensors. Actually the coal gasification or coal gasifiers were developed and licensed by many technology licensors. Later on the concept of biomass and waste gasification came and some other companies worked on it and they had licensed their technologies. So here some important technologies licensors are tabulated for entrained weight, bubbling fluidized weight, circulating fluidized weight and plasma gasifiers. From this table we see that, as mentioned here, most of these above biogas or waste gasifiers are developed after 1980 and up to 2010 the capacity of these gasifiers was less, that is around 500 ton per day. But after 2010 the capacity of this type of gasifiers has increased and now up to 3000 ton per day capacity is available. Now we will see the flow sheets of plasma gasifier. As the mechanism is changing for plasma gasification, obviously the flow sheet will also be changing and we will have some discussion on that, the change in flow sheet in the plasma gasifiers or in plasma gasification process. So the main change will be with the pretreatment. In case of entrained weight gasifier, pretreatment is essential, but in case of plasma gasifier no pretreatment is required. So the waste can be directly charged to the gasifier without any pretreatment, can be charged. Another is we do not need to supply oxygen air, in spite of that we will give external source very high voltage. So voltage that it can generate 100 megawatt per meter cube power density. Then the syngas which will be generated here, the quality will also be different with respect to the syngas generated in conventional gasifier. In this case the acid gases will be neutralized and will be converted to molecules like say HCl, not chloride, the HCl will be available in this. So sulfur will be present in elemental sulfur. So when the syngas cleaning and conditioning concept will come, so during the cleaning time we will get through syngas cleanup we will get HCl, we will get sulfur. Unlike other gasifiers we get acid gases H2S etc., and we again convert this H2S to elemental sulfur, but here directly this conversion takes place. This is major difference in the flow sheet, and then when it is coming the syngas, it can go and it can be used for the steam production and then steam turbine. So steam turbine, so electricity, and this gas after this cleanup we will get clean gas, and that clean gas can be used in turbine because the high temperature is there. So that can be used in gas turbine, and that gas turbine, the gas exhaust of the gas turbine will go for further combustions and for steam productions, and then electricity we can get. So this is the flow sheet of the plasma gasification process, and we have seen some differences between this flow sheet and the conventional gasification flow sheet, which we have discussed in the first part of this module. Here we will see some biomass and waste gasification plant around the world. As evident in this table, around the world the biomass and waste gasification plants are available, and these plants are available since 1990s. Here some lists are given in Australia, Brazil, Canada, Germany and Sweden. So, all those plants are basically based on biomass or municipal waste, and most of these are producing electricity. They are not going for any other chemical synthesis except one or two. Why so? The reason is that the price of the product and the competitiveness in the market. So, to make the process competitive, the process should be of very high capacity, the production capacity should be very high, but biomass and waste gasification process produces less amount of syngas. So, less amount of syngas cannot be processed economically in with comparison to other processes. That is why we are not getting any other applications like except one or two. But recently that the development is going on, how to improve the economy of the process by using compact reactors, and in that case this process will also be more suitable, the biomass and waste gasifications will be more suitable. At last of this module, we will compare the incineration and gasification process. So, for the comparison, we will identify some parameters and we will compare these two thermochemical conversion methods. So, purpose, one is purpose, another is process types, raw gas and its utility, slag and its utility, and your pressure. So, these are the parameters, and if we compare these parameters, we see here the purpose is different. Gasification is to produce intermediate heating value containing gas, the gas which will be having intermediate heating value, and combustion is to produce flue gas and to extract heat from the waste material, and both are thermal process, but gasification takes place with controlled amount of oxygen, whereas the combustion is excess amount of oxygen. We have discussed the R value in the previous module. And raw gas, the gasification contains H2CO and no NOx, it contains nitrogen or NH3 if air is used or PM, but in case of combustion we will be having major CO2 plus H2O, we will get NOx, we will get SOx if sulfur is present, and if sulfur is present, in this case we will get H2S. And solids, we will be getting char or slag. So, char in case of gasifier can be used as fuel, solid fuel, and slag can be used as construction material, whereas for combustion we will get fly ash and bottom ash. So, bottom ash we have to go for line filling, or it can be used for concrete also, and this gasification requires higher pressure than atmospheric, but combustion works well under atmospheric pressure. So, these are the basic difference between these incineration and gasifications. So, all these processes have their own advantages and limitations, but both of these processes are important thermal processes for the conversion of waste to energy. So, up to this in module, and we will discuss in the next module on syngas utilization. Thank you very much.